Okay, here we have a different problem trying to figure out limiting reactant and theoretical yield. Trying to find the theoretical yield of carbon dioxide in liters, assuming this is all at STP. So we have 15 grams of propane and 35 liters of oxygen. Notice again that the chemical equation is balanced. If it wasn't, you'd balance it before you started. It's already balanced though, so I can just simply convert to moles and go from there. So I'm going to divide this by the molar mass, which is 44.11 grams per mole, and that gets me 0.34 moles. To convert 35 liters of oxygen, I'm going to divide to moles. I'm going to divide that by 22.4, the molar volume of the gas, liters per mole, and I get 1.56. There we go, 1.56 moles. Okay, but again, don't forget, you have to divide by the coefficient, in this case here, 5. So I divide this by 5, and I see that I get 0.31. This is my lowest number. See, lower than that. Therefore, this is my limiting reactant. Okay, so I'm going to figure out then how much carbon dioxide I am going to produce by using the volume of oxygen. So here's what I'm going to do. I'll show you the long way, then I'll show you the shortcut. Here's the long way. So 35 liters oxygen, divide by 22.4 liters per mole, multiply by the mole ratio, and then I'm going to multiply to get from moles of carbon dioxide to volume of carbon dioxide. I'm going to multiply by now 22.4 liters per mole. Okay, and the answer I get is 21 liters. Now, the shortcut. You'll notice that right here I divide by 22.4, and right here I multiply by 22.4. In effect, those things cancel out to 1, because 22.4 divided by 22.4 is just 1, which means that all I really have to do then, when I'm converting a volume of one gas to volume of another gas, all I have to do is multiply by the, the mole ratio, okay? So if I multiply by the mole ratio, I get the answer. And go ahead and double check it, and you can see that 35 times 3 over 5 equals 21 liters of CO2. That only works if you go from volume of a gas to volume of a gas. Okay? So that's how we do that. In the next video, I'm going to show you how to figure out how much excess reactant remains after the reaction.